Hello everyone. In this video we are going to discuss about one of the examples of constraint satisfaction problem called as cryptarithmetic problem. So we'll discuss the concept behind the CSP and see how it can be applied for the cryptarithmetic problem. We will also see concepts like forward checking, different types of heuristics like MRV and LCV heuristics towards the end of this video applying to this script arithmetic problem. So first, CSP stands for constraint satisfaction problem, which is used to solve the problems wherein it satisfies a set of constraints on a set of variables. Broadly, CSP contains three components: variables. We have each variable have domains, and these variables together forms constraints, and these constraints can be unary constraints, binary constraints, or global constraints, which means that it can be a single variable constraints or a constraints formed by two variables or constraints formed by multiple variables. Let us apply CSP to crypt arithmetic problem. So the crypt arithmetic problem deals with a problem, an arithmetic equation, something as given here, and we try to assign values to these variables which come from the domain of those variables and also satisfy these arithmetic equalities. So let us see how this can be solved. And so here the variables are all these letters, and each of these variable can take values from 0 to 9, but these are the constraints. The first one is the starting letter should not be 0 and no two letters should have the same number, and when alphabets replaced by numbers, the addition statement should hold. So satisfying these constraints, we need to assign these variables with a value so that we got a solution which satisfies this arithmetic equation and also satisfies these constraints. So let us see how we can solve this problem. So let's start representing this problem in the form of an addition operation, where here we have C1, C2, C3 and C4 are the carries, which can be either 0 or 1. And we also saw that the first letter should not be 0, so both S and M are prevented to be 0, and all other variables should, and no two variables should have the same values. So this is an all diff constraints, so all the variables will have different values, no two variables will have the same value. And this is, so we need to apply CSP to this particular problem and obtain the solution to these values. So let us see how this can be done. So let's start with our first constraint, and also let's express these addition constraints also. So the first addition constraint is so these are d plus e is equal to y plus 10c1. So when you add this d and e, there will be a value y which will be the units place and or the ones place, and you have a carry c1 which is going to be either 0 or 1. So that can be represented in this way: d plus e is equal to y plus 10c1. And suppose if c1 is 0, so it would be only one's position. If c1 is 1, it would be more than 10, so it can capture both the values. So in the same way, now we can express the second arithmetic constraint also, which is n plus r plus c1 is equal to e plus 10c2. So the same reasoning goes here. C2 can take 0 or 1. If C2 is 0, it would be less than 10 value. If C2 is 1, it would be more than 10 value. In this way, when we apply for the other, we get that E plus O plus C2 is equal to n plus 10C3, and S plus M plus C3 is equal to O plus 10C4, and we already know that the first letter should be 1 and it should not be 0, and therefore C4 should be made as 1. So C4 equal to 1 and M equal to 1, and this S also should not be equal to 0. So these are the constraints we have. So let us now start applying CSP or to solve this problem. So in CSP, the core idea is to backtrack, to apply backtracking. Backtracking is nothing but the DFS algorithm. We try to apply values to the variables and we go deeper and deeper until there is any violation. If there is any violation, we backtrack and go to another set of variables and check for consistency. So let's start with the first value, which is M is equal to 1. So we prefer this because there is no other value for M. So thereby a lot of pruning can happen. So each time when we do a brute force kind of a thing, there are around 8 variables and 10 values it can take. So in total there will be 10 P8 combinations, which is too huge. So in each time when we prune it, the number of search combinations would be reduced drastically. So when M is chosen as 1, because of the constraints, all the searches with M equal to 0 are pruned. So in this way we try to choose carefully so that our set space decreases and also we obtain the solution for this cryptarithmetic problem. So let's put M is equal to 1. So that is the first value which we got. So once we assign M is equal to 1, so when we, and C4 is also 1 because the starting value should not be 0. So when you assign M is equal to 1, so what we are left with for S is, since we know that C4 is 1, which means that this value should be, the addition value should be greater than 10. So we try with the large values. So here we try with S is equal to 9 and S equal to 8 is also valid, but because when S is equal to 9, so 9 plus 1 is 10. So even if C3 is 0, there will be a carry. C4 is equal to 1. We can even get with 8. If S equal to 8, 8 plus 1 is 9 and C3 should be 1, then we can get a carry. So both are possible. So let's start with S is equal to 9. So when S is equal to 9, 9 plus 1 is 10, so 1, and we can choose C3 as 0 and O also as 0 because 9 plus 1 is 10. So all these 3 has been, so 0 is occupied with O variable and 9 is occupied to S variable. So in this way, once we have completed this, we'll go to the next one and we can see what are the possible values which are left over, and we choose one by one and try to assign it and check if there is any feasibility. I think we cannot assign E to 8 because if you assign E to 8, 8 plus 0 is 8. If C2 is 0, it would be 8, and both two variables E and N cannot have the same value, and therefore so if C2 is 0, E and N would be the same values. So if C2 is 1 and if E is 8, 8 plus 1 will be 9, but 9 is already taken by S, so we cannot have E to 8. So let's take the next bigger value, which is 7. So if you assign E with 7, so 7 plus 1 is 8, so N can take 8. So N is also assigned to 8 now. So we have 7 plus 1 8 and there is no carry, so everything holds. So once we got N is equal to 8, we have to assign a value to this. So it seems like we should get the addition value as 17. So N plus R plus C1 should be get 17, and to get 17, the one way to get is R should be chosen as 9 plus 8, but we cannot choose it because S has already taken that value, and we cannot choose 8 because 8 is already taken. So we don't have a value for this. So if you assign say 7, which is also not possible because we have taken for E. So if you take 6, 8 plus 6 is 14, and we cannot get the 17. So it is not possible with E is equal to 7. So there is a violation, so it is becoming inconsistent. So we kind of stop that there and we go back to a new value. So we start with E with a different value. So instead of taking 7, we can actually go with 6. So when you take E is equal to 6, the same way 6 plus 1 is 7, so N would be 7, and 7, and we can always take C1 as 1, so that will result in 8. And if you choose R is equal to 8, 8 plus 8, 16. So this relation holds. So let's apply that. So R is equal to 8, and now this relation is satisfied. Let's see if we can assign a possible values for D and Y. So since C1 is carries 1, so it should be more than 10. The only value which we can use for D to make it 10 is 4 and 5. If we use 5, it will become 5 plus 6 is 11. So Y should be 1, but 1 is already taken by M, so we cannot have it. And if at all, if you take 4, 6 plus 4 is 10, Y is equal to 0, but 0 is already taken by O, so that is also not possible. So therefore now we cannot even pursue with E is equal to 6. So let's now move to a different value for E. So let's assign E to 5 or 5 to E. So when you take when you assign 5 to E, so these are the values which have been assigned. So 5 plus 1 is 6, so N would be 6, and 6 plus 1 is 7, and 7 plus 8 is 15, so which also holds this relation. So R can be kept as it is, which is 8. Now we are left with the D and Y. So D can take value, so it should be more than 10. So more than 10 you can obtain. So with 4 we cannot get it, so the only value which is left is 7. So D should be 7. So 7 plus 5 is 12, so the Y should be 2, and 2 is also vacant. So in this way we can assign 2 to Y and 7 to D. So this is how we can obtain the solution for the cryptarithmetic problem. So here the important idea is, if you do a brute force search, the search space is huge. Instead we want to reduce that search space by appropriately pruning, and also by choosing the variables. Properly choosing the variables can also reduce the search space. So let's see those concepts also applying to this cryptarithmetic problem. So let us see more details. So here when C4 is equal to 1 and M is equal to 1, which is the first constraint when we have applied, so what has happened is it has eliminated the value 1 from all other variables. So this is an idea called as forward checking, thereby you limit the values, the possible values for other variables, thereby a lot of search space can be reduced. And so this would be the search space. So M belongs to 1, S is also limited to 8 and 9, and O is taking only 0, and so on. The rest of the values are limited by or we don't include 0 and 1 into these other values. So that is one way to reduce the set space. And also we have so the core idea is backtracking search. Backtracking is nothing but the DFS, depth first search. So first we assign value to the variable and check for constraints, and if it is consistent, we move to a next variable. If it is not, we backtrack and check for other possible values. So while we are doing this, we have an option to choose which variable to be pursued. So we have a heuristic to decide which variable to be pursued, and that is called as minimum remaining value heuristic. It says that choose a variable which has the smallest remaining domain. For example, if we have M is equal to 1, and once you have assigned M is equal to 1, the other variables have a higher number of values, possible values, but S can take only 2 values. which limits, which is a better heuristic to consider, because we would reach to the space very quickly. So this is one idea, and we also have a least constraining value heuristic. So this heuristic is all about choosing the variable, and this heuristic is all about assigning the value to a variable. So it says that when while assigning a value to a variable, pick the value that leaves the most options for others. So when you assign a value to a particular variable, it should allow possible values for other variables also. So that is the heuristic which we use here. So these heuristics will allow us to obtain the solution to this problem in a more efficient way.